Imagine a building in which the thermal zones could dynamically move and follow the sun path to adjust the amount of heat and light absorption. My research builds up on the theory of biomimicry and its dual promises of sustainability and innovation to develop a framework for designing bio-inspired energy-efficient buildings. I've been able to create a framework which is called ThBA, which stands for Thermo-Bio-Architectural Framework. And this framework has two sides, architecture and biology. In the biology side of this framework, I've been able to kind of categorize and generalize all the thermoregulation strategies that animals and plants use to adapt to the thermal environment. Using this framework, architects would be able to start with a thermal challenge, a thermal problem in a building, and take a series of steps and find the relevant inspiration, the relevant thermoregulatory solutions in nature to design sustainable buildings. Another side to this story would be creating a building which are like living organisms. Maybe buildings are more similar to plants rather than animals. One of the reasons might be just the degree of movement we can see. For example, there is a kind of movement used by plants called thermotropism. And in this strategy, plants turn towards sunlight. If you look at the cells in the leaves of plants, morphological properties of these cells plays an important role in the amount of light transmission. So light could transmit deep into the leaves. What we do in architectural design, we use atriums. Future generation of sustainable buildings would be those buildings which are exactly like living organisms. The current state of technology doesn't allow for the 100% replication of those strategies. More research needs to be done in this area, and hopefully with more improvement in technology, we would be able to create those buildings.